Welcome to today's class on one-way ANOVA. ANOVA is the same as analysis of variance. When do we conduct this? So we conduct ANOVA, one-way ANOVA, when your data sets do follow the parametric assumptions. And we also, in this context, assume that your data set is normally distributed. It is good for comparing 3 or more independent samples or groups. So in this context, there is a company called Company X, and that construction company called X, they are assuming that, or I'm assuming that there are 3 categories of professionals that work for this company, and it's made up of architects, quantity surveyors, and site managers. I'm assuming here that there's no differences between the means of hours that these professionals work. That's going to be my null hypothesis. Alternatively, it's assumed that there are differences in the means of these 3 groups. So to test this, I'm going to use ANOVA because these are 3 groups. So what I want to say is that you can use it to compare so many groups, but the condition is that it should be 3 groups or more. If you want to compare 2 or 1 sample, then go to my YouTube channel and then check the videos that I've put out there. So without wasting time, let's go into this. So first, you go to File, if this is the first time that you are going to do this in Excel, and then you click on Options. When you click on Options, this will open for you, and then you look out for add-ins. You click on it. Then the add-ins, when you see Excel add-ins, you just click Go. When you click Go, to open this for you, if your dialog box has already been ticked just like mine, then you leave it. But if it does not, you tick it, you mark it, or you tick it. So analyze 2-pack. You click OK. Once you click OK, then you come to the data. So the data, you click on data, and then you look out for data analysis. It depends on where it is located. Just look for it. Once you click on data, look for where you can find this. If you can't locate the data analysis, then go back and start the process again, where you click on File, you look for Options, and then you just look for add-ins, and then analyze or analysis 2-pack. So I'm going to click on data analysis. I'll pick ANOVA in this context. There are different forms of ANOVA, but in this context, we are using the ANOVA single factor. In my subsequent videos, I'll use the other ones. Okay, I'll click OK, and then this will open for me. Once this opens, what I need to do is that I need to select this, including the labels or the titles. And then here, I'll just click, if this has not been ticked already, you click on labels in the first row. So the first row become, yeah. And then the alpha, it depends on the alpha that you want. That's the significance level. If yours is 5%, you maintain, the default is 5%. But if yours changes to 1% or 10%, then you have to make changes to this. Then you look out for where you're going to put this resource. So here, I've decided to put a resource somewhere here, the output range. So once you put it, you just click this and you click OK. The results will just come out. Now let's look at how the results look like. Okay, so here you can see that I have all the 3 groups and the 7 days of that they worked. That's to count 7. So 7 observations, 7 observations, 7 observations. So the sum refers to when you add them together. So here is 78, 80, 91. On the average, the sum divided by the count, then the variances. Now let's come to the source of variation. which is the main reason why we conduct the ANOVA. So there are two sources of variation is between the groups, so the three columns, or within the groups, within. Okay, so the first one that we look at is the sum of squares of variations. So the sums of squares of the variations is giving us the variations in the groups, between the groups. So how do we get this? So to get this, you take the, it will give it to you, or like to work it out. The Excel will work it out for you, which in this context we have 14. And then within the groups too, it has also been worked out. And this is the value. Then we come to the degree of freedom. How do we get a degree of freedom? So to get a degree of freedom between the groups, so there are three groups. So K minus 1. In this context, it's going to be like K minus 1, which K in this context refers to the number of groups, which is 3 minus 1. So 3 minus 1 is 2. And then we have the within groups. How do we get a within groups? You take the total observations. So how many observations do we have? It is 3 times 7, which is 21. This is going to give us 21. Then minus the total number of groups. We have 3 groups, and that will give us 18. Okay, so the total observation, which is 7 plus 7 plus 7, which is 21, minus the number of groups, which is 3, and that will give us 18, as you can see there. Okay, then we come to the mean squares. How do we get a mean squares? To get a mean squares, you just divide the sum of squares divided by the degree of freedom. So this 14 divided by 2. So here is 14 divided by 2. For the within groups, is the 282.5714 divided by 18, and that will give us this. Okay, good. So the final thing to do is to look for the F statistic. How do we get the F statistic? The F statistic is going to be, we'll divide the between groups by the within groups, and that will give us that, as we can see there. Okay, so that's the F statistic. Okay, so the F statistic in this context is just like doing the T statistic, where you have, or undertaking a T test, where the T statistic become your main variable that you use to determine whether your solution is significant or not. So in this context, the Excel has also given us the p-value. Okay, so our significance level that we put, if you remember, was 0.05. So when your significance level is less than 0.05, then you reject the null hypothesis. In this context, the p-value is far higher than the p-value that we are getting for this result. Therefore, what is going to happen is that we'll rather accept. Okay, so here the p-value is rather greater than the significance level. The significance level of 0.05. So in this context, what we'll do is that we'll rather accept. So we're going to accept this. We'll accept this and say that there's no differences between the means. That's what it means. Or you can also use the F statistic and then the F critical. Okay, so in this context, the F statistic is less than the F critical. How do you get the F critical? You can look at the F critical from the F table. Okay, to get this. Also, anytime your F statistic is less than your F critical, statistic is less than F critical, then you have to accept the null hypothesis. But if it was opposite, if it happened that our F statistic was higher or greater than the F critical, then we will reject the null hypothesis. Okay, so that's for the Excel. Now let's conduct the same analysis in SPSS in case you have SPSS and you want to conduct this the same. So we are going to use the same information to conduct this. So I'm going to open my SPSS and then see how it will go. Okay. So in my SPSS, I'll go to the variable view. In this context, I'm dealing with two forms of data. So the two forms of data I'm dealing with here is the number of hours that these professionals work, and then the type of professional that they are. So I'll just say professionals, construction professionals in this context. Okay, so the number of hours is numeric, and then the professionals are also numeric, but I need to, determine or put out the measure of the professionals and hours. In this context, I'm going to make them more nominal because they are going to help us to know whether they are architects or they are quantity surveyors or site managers. But here, I would say that they are more of skill, but let's see how things will go. I will not. To change the professionals, I need to let us know the kind of professionals that they are. So here, I'll say 1 is for the architect, 2 is for the QS, which is quantity surveyors, 2 is 2 my time, and then 3 is for the site managers. Is that okay? So I'm going to assume that there's no decimals. The same thing also applies to this. And then I'm going to put them in the center. The figures, I'm going to copy them and put them in the center. Okay, now let me come to where I put the data. So in terms of the hours, I'm just going to copy them from here. So this is for the architect. So the first 7 is for architect. I'll just put them here. And then the next 7 for the quantity surveyors. And then the next is for the site managers. Okay, so I need to determine the kind of professionals that they are, if you remember. So I said 1, 1, 1, 1, 1 for the first set of professionals, which is for the architect, and 2, 2, 2, 2, 2, 2 for the QS, and then the 3, 3, 3, 3, 3, 3, 3 for the site managers. Okay, so I have all my data set. Now I can run the ANOVA. Don't forget, I mentioned that this is parametric, it's not non-parametric. So therefore, we will use the compare means and proportions. Compare means and proportions, and then we go down to select one-way ANOVA. Now we put the hours here, which is going to be a dependent variable, and then we need to set the factors. And then now we can click on options to determine the kind of analysis that we want to see. Here it depends on you as to what you want to see. Okay, whatever you want to see, you can show everything. Yeah, okay, so let's go. And then I click OK. Now I have my results. So what we can see here is that we are getting the same thing. Let's go straight to the ANOVA. I'll come back to explain the other things, then we end it. So what we are seeing here is that we are getting the same thing that we saw from the Excel, where our F statistic was less than the F critical, and therefore we accepted the null hypothesis. And then our p-value was higher than the significance level of 0.05. Therefore, once again, we accepted the null hypothesis. When it comes to the homogeneity, it seems that these are also insignificant using the Lavin statistic. The significance are also, these are also not significant. That means that there are no significant differences between them. And then also when you come down, you can also use a Welch. You can also use the robustness of Welch and Brown-Forster. And they are also, in a way, also showing that, yeah, these are also insignificant. But in this context, it seems we are breaching the normality condition. It seems the data set is not normally distributed. To confirm this, you can confirm this by conducting a full normality test. Yeah, because it seems we are breaching the robust test of equality of means. Yeah. Okay, but the main focus should be on the ANOVA. And the ANOVA is saying that there's no significant differences between the means from here. Okay, thank you very much. And I will encourage you to follow me and watch my next video, which I'm going to conduct another test where you have 3 or more groups, and then the data set is non-parametric, or you have breached the normal distribution assumption. So follow me and let's keep learning together. Take care and see you soon. Bye.